So if we share this.
It looks like something's coming up here. Oh, good. I see a picture of you, I think.
Yes.
Yeah. So no, that's good news. That's one of my main worries besides the recording was that we wouldn't be able to give you screen sharing permission. So looks like at least we're good there. So so fantastic. Yeah.
Cool. So
Glad we did that. So that's one hurdle.
yes. So that's the front page. So yeah, everything would work from there.
Excellent. Excellent.
Shall I leave that on or
It wouldn't hurt to leave that on, and I
okay.
will adjust my view so that I can hopefully see people as they start to join. So exit full screen, and that should work. Yeah, let's leave that up there, and then people know instantly that they've arrived at the right spot.
Okay. The only thing though is, do I need to have my camera on at all for this?
You don't have to. We do it sometimes, but there's some bandwidth issues sometimes when we do that.
Okay.
So I guess we'll see how many folks join. But yeah, it can be a problem with the camera.
Okay. Well, I
I'll
mean,
just temporarily turn mine on so we can at least see each other. Hopefully that works. Oh, that's weird. What is it doing? Oh my goodness, that's weird. Hang on, I got to unplug my camera and plug it back in again. There is something very strange going on. Oh, every time I go back and forth between Zoom and Teams, it messes with the device settings, and I don't understand it, but I'm sure there's.
Fair enough. So I've just turned my video on.
Okay, so I will put. And let me try this. Okay, that's good. And then video. It's not, oh, it had the wrong camera. I wonder if that's the problem. Let me plug it back in. Let's see if it sees the new camera. I think it's actually working. So now how do I so I should be good. I should just be able to, yeah, if I just close that and then start my video. It's working. Okay.
There we go.
Hello.
Hello. Nice to see you.
Yeah, good to virtually see you or meet you too. Yeah, it's all these things. It's always nicer to do when there's like one or two people on the call than 30.
Yeah. Do you have any idea who might be joining, or are we just going to see what
we sent it out to a pretty wide group, so there's a couple of different groups within INCOSE, the infrastructure working group, of course, the transportation working group, which I'm the chair of, and then there's also the I think it went out to the Smart Cities Initiative, and then also it went out to I sent it out to the Systems Lifecycle Engineering Subcommittee at APTA, which is a whole other bunch of folks that potentially could show up. So it gets a pretty wide distribution, and hopefully it went out in, I think, in enough time. So we've had as many as 60 on the calls. It just kind of depends the time of year too. In the summer it drops off understandably quite a bit.
Over the summer.
Plus the INCOSE events will sometimes prohibit people from joining, because if there's an INCOSE event going on, we try to schedule these away from big INCOSE events like IS or any of the regional conferences, both in Europe and North America, but sometimes they just collide, or they're days or a week apart, which is unfortunate. But I just say, well, we're all volunteers, so nothing's we're doing what we can do.
Fair enough.
That's my excuse. Yeah.
Yeah, no, I mean that's all right. It was just to have an idea, really. But yeah, we'll see who turns up. You might be aware, but so this was presented at ASEC in the UK last November.
Okay.
So it's published in the conference proceedings in ASEC. Well, of course, not everyone gets to go to those, so just a chance to do it again for those who haven't been able to see it before. So yeah, we'll see what comes out.
Yeah, no, that's perfect. We often actually do that, you know, where folks have maybe presented at a a conference. It's been a long week and it's only Thursday.
Yeah.
You know, where they presented a paper or something, and some of the conferences, especially the APTA ones, they don't do any hybrid stuff like INCOSE does. So you're either there physically or you're not. You know, tough luck. I disagree with that policy. I think INCOSE's got a better approach, you know, with the hybrid, because some people are on, you know, either don't have the money, especially if they're from a transit agency in the US, they don't have money to travel at all, really. You know, it's very limited. They pretty much, you know, they could maybe go to one conference a year, if that. So I think that's a bad policy. But then what we will do is, through this third Thursday thing that we do, you know, between the RIG, INCOSE North America, and APTA, which we have the MOU with, you know, we try to make sure that people get another shot to, you know, at seeing things. So this is perfect, you know, to do that.
Yeah, sounds good.
Since there's only three of us, welcome, Sanjeev. We could just all introduce ourselves temporarily. I don't know if we'll have a chance if 30 people or 40 people join, but oh, here we go. Some folks are joining now, so great.
Oh, that's Bruce.
Here we go. Yeah, Bruce.
Hi, Dale.
Hi.
I think I was present when you gave one presentation in this webinar series. I remember correctly, it was about the system engineering and decision making, if I'm not mistaken.
Sorry, just didn't catch that last bit.
System engineering and decision making, if I'm not mistaken.
Oh, okay. Yeah. We've had, and we've had a bit of a gap in getting these things up into our YouTube channel, the TWG YouTube channel. So in theory, they're all going to be there. It's just, you know, getting folks to do it. The few volunteers that are actively, you know, engaged in this, sometimes what's that old expression, that like the one-armed wallpaper hanger type situation, and we just get overcome by day jobs and other volunteering events. As soon as this closes, I've got to jump in my car and head down the highway to the Chicagoland INCOSE chapter meeting, where I'm giving a very small presentation, and then we have another presentation. So it's a lot. Oh, there's Bruce. Hi, Bruce.
I don't know if you can hear me.
Yes.
Yes.
Hi, Bruce.
Hello. Have you lost your first syllable one day?
No, I haven't. I've claimed it back now.
Right. Oh, you're right. Okay.
Yeah. I lost it for about 6 months in a brief stint I did with Jacobs. FYI, I work for Siemens now.
Right. Okay. Because they can get spell your name right. Although I have to say, on the Zoom chat at the moment, it says Yewande, and next to your.
I can't see that, so unfortunately, that might just
Oh, well, there you are.
Yeah, that's what's coming up in your video window as well. Just one day.
Okay, I think I can fix that. There we go.
Yay! People always miss the last T off my surname.
Yeah. I guess as well, sometimes people have variations of similar names, and if you've seen one spelling before, you sometimes just make assumptions, don't you?
That's right. I'm used to it. It doesn't make me cross.
Well, I do point it out every time it happens. I had a student, I have to say, which I shouldn't say this, but I will, hands in a dissertation report. So this is 2 months' work, 2.5 months' work, a third of their credit. I supervised their project and they spelled my name on the front page. Don't do that. I don't advise it. They didn't lose any marks. But I noticed.
Can I just check? Do these last half an hour or an hour? Because it says an hour in the flyer, but it was half an hour in Mike's email, just to understand how much time I've actually got for the presentation itself.
We've been shooting for 40 minutes, just
Okay.
but whatever you're comfortable with. And we should probably do you want to accept questions live, or do you just want to go through the presentation, then we have the chat at the end? What's your preference?
If I can go through the presentation, I'll try and keep
Okay.
that to about 25 minutes, and then plenty of time for questions afterwards, and then I can skip back to whatever might have triggered the question.
Sounds great.
Cool.
And then we also leave a few minutes for just, general announcements, if the RIG has any announcements, and INCOSE UK, and depending on whether we get any APTA folks showing up. It went out to the whole population. So, and I just jumped off a presentation that ICE was giving on railway failures. So that was interesting. I couldn't attend the whole thing because I was trying to get this bit up and running.
That's good.
Marcel van de Ven he was on that call too. He's the only other name I recognized. They had 115 people on that call.
Wow, that's
yeah, it was very impressive. It's the first Institute of Civil Engineers call or webinar that I'd been on, and it had the word railway in it, so I signed up. So yeah, they obviously get a pretty good crowd.
Many times the size. The membership is many times the size of INCOSE UK.
Yeah.
I think they're by some margin the biggest engineering institution, certainly in the UK. The what's the US version? I forget. Sorry.
Oh, American Society, ASCE, I think, American Society for Civil Engineers.
That sounds.
Yeah.
Well, those guys were here first.
Indeed.
I was talking to a civil engineer a long time ago about the history of civil engineering, because originally it simply meant all engineering that was not military engineering. If you weren't a military engineer, you were a civil engineer. But he said the history of our discipline has been people nibbling bits off from time to time. So the mechanical engineers separated, and then new forms of engineering, electrical engineering and electronic engineering. And project management used to be part of civil engineering. Quantity surveying used to be part of civil engineering. So it used to be everything pretty much. And then they've just ceded territory again and again to other institutions. That was his view.
Interesting. Yeah. Huh.
Oh, so just the four of us.
We've got a few more while we've been talking.
Oh,
let's see. Yeah, 1, 2, 3.
I should. I'll stop chatting and let you take control of events. I look forward to the talk.
Well, looks like. Oh yeah, there's Marcel. Well, greetings everybody. We'll probably get going. I'll leave a couple more minutes. Hi, Marcel. I noticed you were on that ICE call that I was on earlier.
Yeah, correct.
I
was
missed
there.
I missed the conclusion. I was looking forward, but they said they were recording it, so maybe we'll get a chance to take a peek at it at some other time. But it was an interesting, the Swiss cheese approach was very interesting.
The way they approach
Hello,
risk
Dale.
management was quite interesting. Yep.
Yeah. Hello. That sounded like Mike. Oh, there's Mike.
Yes,
Yeah.
it is.
Hi,
See,
Mike.
Yewande, she's in San Francisco. Well done.
Hi, Mike. Nice to
All
see you.
right. I see you're also presenting at the for the IMEC in the
It's-
end of this month.
Yeah, it's next Thursday, next Tuesday actually.
Yeah.
For the IMEC, it's a joint event with the IET, and that one's going to be live in Swindon. So if you fancied driving down from Bristol, then yeah, you're welcome.
I see it live. So they'll
Yeah.
be at the Steam Museum, will it?
I
Or
probably need to
somewhere
double check that, to be honest.
Okay.
Yeah, I know I have to be in Swindon, but yeah, I'll check the postcode before I actually set off.
That's where they tend to have them. So
Okay.
it's a nice place. If you're in the rail and Steam Rail, that's the place. It's where the Great Western's big shops were. It's a big museum factory.
Yeah, should be good. Should be good.
Mhm. Okay, so you're all set up. It sounds like we're just waiting for people to join.
Yeah, I think so. I wasn't able to join as a whatever the master of ceremonies, whatever the correct term is for Zoom. So I wasn't able to, but Yewande and I got the screen sharing working and confirmed. So we just thought we'd leave it up so as people join, they know they're in the right spot. But I wasn't able to turn recording on and off. I don't know if you have that capability, Mike.
It came on when I logged in. I think it came
okay.
on. We checked.
Well, I sent an urgent email to IT in San Diego, begging them to please give me whatever the one-time code is, because they've done this thing where I've got the credentials to get into the Zoom 16 meeting directory, but now it's asking me for a one-time code, which it sends to INCOSE IT. So that's not useful.
Let me check mine. Because it was oh, here it is.
Worst case is we'll edit the first half hour of the chat out.
Okay, let me check if it showed up in my emails. And nope.
Okay, well, we'll just at least it's being recorded and we can always edit it out. So
okay. Let's see. Let me start. Okay, I think we have 13 people here, and I want to start the session. Yewande Gbadegesin will be our speaker today. She's going to be speaking on ESI assurance, the engage, synchronize, and integrate process for engineering assurance. And she has a long background in rail and also worked at Capgemini. She's worked at Jacobs. She now works at Siemens. I guess that's the one near Bath, is it?
So I move about a lot. I'm based in London, but yeah, I do visit Chippenham once in a while. Yeah.
Okay, perfect. Well, without further ado, we'll give it over to Yewande, and she can provide this. Now, this presentation was also presented at INCOSE ASEC last year.
Yes.
And I think you got an award for this, right?
No, it was the other Capgemini people that got an award, not me.
Okay.
I won't take that
Well,
away from
it was noted as one of the good ones. Yes.
Thank you.
So Yewande, it's all yours.
All right, cheers. Thanks, Mike. Thank you for having me. Thank you for the opportunity. Appreciate, as Mike said, this was presented at INCOSE ASEC last year, but that's a limited audience, so it's nice to be able to present to sort of more people. It'd also be nice to see what your questions or comments are on the information that I'm sharing. As Mike said, I have a background in rail industry. I've worked in the rail industry in the UK for about 12 years now. I've worked as a safety engineer, and it's in my experience as a safety engineer that inspired quite a lot of what you will sort of hear from me tonight. And I've also worked as a systems engineer, which is the skill I think I'm using to fix the things I think are broken in the way that I've seen systems engineering done in the rail industry. So yeah, interested to know your views, your challenges as we go through. So I've titled this Engage, Synchronise, Integrate ESI Assurance, or you could call it Easy Assurance for short. And it's about ensuring that we are ready for the future, whatever it is we're doing in assurance. And it's again based heavily on railway experience. So it'd be interesting to see what people think, people who work in other industries, and whether you agree that this is a similar challenge or whether it's different and it's all fixed there. So I put this statement together. I say future-proofing is the ability to adapt to change, and change is inevitable. So as systems engineers, we work on complex systems, and complex systems are introduced usually when we have to make some kind of change to existing infrastructure, or we have to build some kind of complex thing from brand new. And if we're going to survive all the technological advancement that's coming, especially for those of us who have worked in any kind of assurance capability, you know, safety cases or assessment or anything like that, we are moving very rapidly away from the way we used to do a lot of paper-based work, and I'll go through that in detail. And we need to start thinking about how we're going to be future-proof, how we need to adapt to the change that's coming. So I'll go through a few definitions. I'll introduce what I think the problem is, and I'll go through what my approach is to solving the problem, and tell you a little bit about what happened when we tried some of these things in a role in the past. Sorry, I can see chats coming up. I'm hoping that people can actually hear me. And okay, no one's complaining about not being able to hear or see. Okay.
No, you're good. You're good.
Awesome, thanks. So, achievement of systems assurance for high integrity systems typically requires demonstration and evidence that a system meets its specification. So, essentially, when we want to perform assurance for a high integrity system, we want to know it does what it should do, so it's achieving some kind of functionality or intended purpose. And then there's usually the fact that because, again, it's high integrity, there's some kind of risk that needs to be mitigated. And thirdly, there's usually a set of standards that would have been met. What I found in my experience is most of the system engineers that work on what we call the STEM of the systems engineering, they try to ensure that it meets its intended purpose, or the term requirements would usually come up, or functionality is met. So most of the systems engineers I've met would work on ensuring that it meets its intended purpose. But then there's a group of specialist engineers. INCOSE handbook, for example, will define safety engineers, RAM engineers, usability type engineers, security engineers as specialist engineers. They tend to focus on a set of risks, or tend to ensure that we're meeting the required standards applicable to the type of engineering or system that we're doing. So those three things, I think, are the ingredients that we usually need to get the system assurance for high integrity systems. And the specialist focuses definitely contribute to ensuring that the system meets an intended purpose, because if you do meet the purpose, but then certain risks are unmitigated, then it tends to negate each other. So they work closely and very much hand in hand. Now, these specialist disciplines, again, reference in INCOSE handbook list a few of them, particularly safety, RAM, security, and human factors or usability are very popular when you're working in the rail industry. They do have quite a few things in common. They all measure, record, and manage risk in some way. They all look at some kind of emergent property, using cross-functional working groups, hazards, and such type of meetings. They require independent audits sometimes. They comply to standards. They use techniques that tend to be assessed throughout the system development, and they provide some kind of assurance case and supporting evidence at the end of the day. So for me, it kind of makes a question obvious. Well, aren't they doing really similar things? So shouldn't they be doing it all together? But then you start to find that they use very unique vocabulary for their risk management. And a lot of this is based on historical reasons. I'll go a bit more into that as we go through. They use very unique approaches to the study of emergent properties. So you would have heard of hazards and HAZOPs if you work in safety, or FTAs or FFAs or that sort of thing, day in the life of something for a human factor or usability assessment. So they're very unique approaches using very unique vocabulary or language. They use separate documentation, separate repositories. The skills can be quite distinct, expertise, usually working very separately using their individual methods. But as the previous slide told you, there is some similarity in what they're trying to achieve and the way they're trying to achieve it, but it does tend to be yet so different in the way that they actually work. And a lot of it stems from the way the standards and the systems have evolved over time. So what I think the problem is, we are in a situation where technology is advancing. In the rail industry, for example, you're starting to see a lot of move towards network-based services for key control functions, central data management systems. You're starting to see more of remote maintenance options and higher grades of automation. What this means essentially is that we're moving away from, again, an example from the rail industry where you had a lot of mechanical type interlockings moving towards computer-based interlockings, now moving towards your ETCS, which is your train control system using over radio type communication. So we're moving away from when it used to be mechanical systems with security of a system being essentially a locked door or a code to get in or anything like that. We're starting to see these things a bit more integrated together. So we're no longer able to physically isolate or separate security or safety functionality from the actual system functionality or system behavior itself. So we do need to start thinking about, if we haven't already in some other industries, we do need to start thinking about exactly how are we going to start assuring the systems that create an efficiency that allows us to achieve what we are trying to get, which is maximum capacity, improved performance, and acceleration of production. So essentially removing quite a lot of the rigor or the paperwork that we're seeing in a lot of things that we're doing today. But specialist engineering practices have evolved in different directions, working in silos, and they're guided by their individual standards. Because of this, the risk of incoherence or incorrectness is increased. Implementing change or performing impact analysis can be very difficult. And of course, the cost of time to market, as we said, because of increased paperwork and just having to bring things together later on, as opposed to having worked through the entire cycle or the development life cycle together, becomes more expensive, and you can essentially get more errors through that. So my quick answer, to be honest, would be, when we go into the standards, I personally don't think that the standards work for us anymore. And we need to start having a rethink of, rewriting some of the fact that I think it's some of the Senelec 501-6 standards that say that talk about security functions being separate from the system, but that's not the case today, because you essentially have security functions embedded into many of the systems that we're trying to introduce into the high integrity infrastructure today. So we cannot immediately rewrite the standards, I'm aware of that, but maybe we can try and adapt the processes. So the approach that I'm proposing is essentially a number of things that I think we can do to start to adapt some of those processes. The first step was, there were a few standards that were sampled. The one on the left-hand side is the INCOSE handbook, and then IEC 61508 is the next one, and the RAM standard, which was EN 501-6 just mentioned, also went into DEFSTAN 00040, which is one of the defense standards in the UK. The Security Assurance Framework from Network Rail was sampled, IEC 62443 was as well, and HF ISO 9241 was sampled as well. I'm not expecting you to read all of that, but two main things I want to draw from that is, one, they all define a specific type of life cycle split into a number of phases that don't necessarily align with each other. The instant you start to talk about contractual boundaries, things can very easily fall apart or be misaligned, because how do you draw a contractual boundary where things are not evenly split? Again, we cannot rewrite the standards that easily or that quickly. So what can we do is go into our processes and understand how they must align. So I look at two key phases of the engineering lifecycle, which is concept and development, and maybe further work in the future can be done to look at some of the rest of the phases, and concept and development basically as defined in the INCOSE handbook. So when we look at concept definition, we've got a system with a context and a boundary, basic system definition, and our system of interest has some technical processes that we enact on it. There's also constraints and influences, some of which we know, some of which we don't know, but they affect our system of interest. at the system boundary, and that all sits in a technical environment. But then the technical environment sits in an operational space with factors that are affecting the technical environment and cause an impact on the system or how the system is developed. That operational space or business environment equally sits inside an organizational culture with additional factors that might affect how the system behaves or how the system is defined. Now, each of the contributing disciplines, and we're talking about specialist disciplines here, needs to have a cohesive view of the system boundary, a cohesive view of the wider context and how the interactions work across these layers. One of the most important things that I found was when change is introduced in any of these layers, how consistent is it actually drawn through the layers, or how consistent is change applied across these different layers, or how can change be managed when it's looked at across these different layers? So essentially, if we've got a change in a system of interest, or we've got a change in a technical process affecting a system of interest, do we actually know the business factors that might affect how that change is implemented and therefore affect how the system might behave or how the system is built? Same goes for organizational cultures. When we need to have some kind of change in a technical processes directly affecting how a system is built, are we actually able to ensure that that change cuts through all the way to the top, and we can get the organizational culture to support the change that needs to be made at the system level? The sizes of the circles also mean something, because essentially it gets more and more difficult and more expensive, and there's more and more time taken as you go into the wider circles. So that's one of the big complexities that you find when we're trying to implement change in the way that we do engineering on the system of interest, and the factors that might affect how we implement change. Each of the specialist disciplines also tend to have a specific target, and when we sum up those targets, they contribute to achieving the overall goal of whatever of the system of interest that we're trying to develop. And then we've got the functional need, usually orthogonal to the target. So essentially, in trying to meet the safety target, it tends to cut through a number of functional needs. Same goes for security, usability, and the rest of it. When we're defining the system boundary, there's also a need to consider the interactions across each discipline. What tends to happen, again, as we mentioned earlier, because these disciplines tend to work in their individual silos, guided by their own individual standards, the actual interconnectivity or interaction between the disciplines is not necessarily seen or considered early enough in the life cycle, and therefore we're not really usually able to understand how they depend on each other or how they might affect each other. One really useful reference I found whilst doing a bit of research for this was in the Capgemini Reveal framework. They've created something called an extended context diagram. So the additional arrows you see there between the usability feature, the security feature, and the safety feature aren't necessarily the sort of relationships that are looked at when defining the system. Usually, each of these features are considered in context of the system or the machine, or in context of the operator or the user, not necessarily in context of each other as specialist disciplines. And this is what needs to happen if we are to start to make things more efficient, to create the assurance for the sorts of systems that we're starting to see evolve today. And one of the things you start to find, especially when you look early enough, is that it's not uncommon that sometimes targets might be conflicting or contradictory and need to be negotiated. And sometimes one of these reasons, again, reference to the rail industry in the UK, is you tend to have multiple stakeholders for complex systems. When you start to engage your stakeholders early, you start to see some of these contradictions or conflicts early, and then you can start to negotiate the priorities. So early engagement for stakeholders is really important. And of course, your specialist disciplines are equally stakeholders themselves. So early engagement, ensuring that we're able to negotiate the priority, negotiate the targets and find the balance early enough is essential, so that we're not having to do the fixes later on, which cost us more money on the long run and could potentially create more errors in what we're developing in the system. There's also the fact that we must represent the boundary in a form that allows consistent translation across the relevant disciplines. Now, this is really difficult because early on we introduced the fact that there's usually specific vocabulary and terminology used within some of these specialist disciplines. And when you look in the standards as well, that's usually an issue as well. So translating things across the different disciplines sometimes could start to create even more gaps or overlap sometimes, which can be as bad or even worse than gaps when they're not carefully managed. So the proposal that semi-formal or formal models make things really a lot clearer and help to translate things better is what we're considering here. After the concept development phase and the system boundary is defined very clearly and consistently for all the disciplines to understand and be able to translate clearly and consistently, the next phase is usually the development phase, which for a lot of systems will start with specification of requirements. Now, in my experience, specification goes hand in hand with risk analysis. So essentially, as we introduced earlier, we are specifying the system we want, the functionality that we want the system to be able to do. But then we're also ensuring that it doesn't do what it shouldn't do. So we're mitigating potential risk. And we are talking about high integrity systems. So the former represents what must be achieved and the latter represents what must be avoided. So synchronization of these activities, I think, is a natural thing. And one of the useful things that we can do to synchronize these activities is definition of end-to-end operational use cases. Again, once we're able to have a consistent understanding and representation of the system boundary, then we might be able to draw these end-to-end scenarios or end-to-end use cases, and then we can step through functionality, considering all the right specialist discipline, considering all the right targets from the specialist disciplines, and we can start to see the relationships across the different disciplines and how they affect and impact the functionality as we build the system functionality or as we specify the system. System specification and risk assessment. The information management solution is also central to the integration. What we find is you tend to have a requirements database. Most companies or most systems would use DOORS, for example, as a requirements database, and there'd be a hazard record somewhere, and there'd be a threat log somewhere for the security specialist, and there'd be some other specialist repository, as many as specialists as you tend to have on a development project. If we can find a way of using a single tool with specific views or unique views for each discipline, this can really help things. Or if it's too difficult to use a single tool, which it can be, and I don't think anyone's invented one yet, the use of well-defined traceable attributes across the different tools is one of the key things that we must start to implement. And one of the things that makes this work is guiding by processes that ensure that change is properly managed. So essentially what we're saying is, if there are keys that allow us to read across from a requirements database into a hazard record, into a threat log, impact analysis becomes very simple to do because we can see how things might affect each other. But then ensuring that, because you may not necessarily have automation that allows you to see how changes, how something impacts something else when a change is made in one area of the repository or through one view or the other. But if we have a process that is well-defined that allows us to manage things, so you understand how to go and do your impact analysis and your traceability, then that can really help. And when it comes to gathering evidence for any of the assessment bodies that need to assess any things that come out or look at the assurance output, this can also be easily streamlined because you've got this integrated information management solution that allows you to see things and allows you to find how things might be related to each other. So the picture that we've got here is just an example, and it's a sort of high-level overview of, you've got that cloud in the middle, which is trying to be an integrated specification. On the right-hand side, you've got a set of attributes representing your requirements. On the bottom side, you're essentially just, what we've done there is just a catch-all and a loose definition of conditions there, where we're saying you have your safety conditions, your security conditions, which could be risks or hazards or whatever specialist name they're called, all linked to an integrated specification. And on the left-hand side, you've got origins of things like your stakeholders and your risk analysis meetings or whatever other source of information you might have, standards or historical information. and then you can have your validation criteria. So this is just a high-level overview of having an integrated repository or being able to do this sort of engineering, this development level, but keeping all your information in a format that allows you to understand how things impact each other when things change, because they will during development. This is another possibly translation of what you saw earlier, which is the Capgemini Reveal framework when it talked about the extended context diagram. The diagram you're seeing on your right-hand side is just an emphasis that each of your specialist disciplines is trying to mitigate some kind of top-level event. But what we also find is sometimes certain causes, certain events in certain specialist disciplines might equally be caused by an event in another specialist discipline. Simply put, a security incident might lead to a safety event, a human error might lead to system unavailability, which then leads to a top-level event. So there's a high degree of interaction that can be found if we're able to do our assessment together. So imagine a situation where we do have an integrated repository. We're really able to see the cause and effect. It might look like a complex model, but it is the model that we need in order to actually tease out some of those details that we don't tend to see until later on during development. And God forbid, sometimes we don't even get to see until during testing or operation. So the bullets on the left-hand side just tell you specific causes and consequences are analyzed by different specialisms. Some causes lead to events in an adjacent discipline, emphasizing the importance and understanding of the extended context. So it's really about that extended context and about the integrated repository for the information. So we can perform robust causal analysis using integrated working groups as well, instead of running individual working groups, which most of these disciplines tend to do. So engage, synchronize, integrate in practice, which is kind of just a summary of, or to wrap up a lot of what I've rattled through in the previous slides. Before we can begin, or before we should begin any kind of development in high integrity systems engineering, we need a consistent understanding and representation of the context of the context of the system that we're trying to develop. And we definitely need representations from all specialisms engaged as early as possible and engaged consistently throughout the development. Risk analysis and system specification are two sides of the same coin. There's no need for them to be siloed. They should be supporting each other to ensure that we're building a system that works and the system that works in the way that it should. Development activities which have similar aims should be synchronized, aligning inputs and techniques as closely as possible. Just as we were saying in the previous slide, when we're doing some of these integrated working groups, we are talking about similar things, but we're talking about specific consequences. As much as possible, we should be synchronizing these activities using the power of the robust engineering we can get from having all of the contributions from specific parties in the same room or in the same sessions. And traceability is crucial to successful development and assurance. Where information repositories can be integrated, evidence of assurance can be very easily retrieved. There's a lot of paperwork that can go into assurance sometimes, and there's no point duplicating, triplicating, or even quadrupling sometimes the evidence that needs to be submitted. The use of this integrated repositories can ensure that information is more efficiently recorded, and we can pull out information more efficiently at later times when we need to submit to assessment parties or signatories or any other bodies that need to assess information for assurance. So I've talked a lot about the concept development, defining the system scope, and I've also talked about development phases. But surely in the later phases of the system engineering lifecycle, I'm sure that we can apply some of the engagement, synchronization, and integration principles that we've talked about. On a couple of reference projects, concept and specification projects that I've worked on, we were able to identify gaps and conflicts early enough within development. What I will tell you is that it does make things a little bit slower at the top because you're taking time to tease out some more details that you may not have seen until later on. However, it does allow more efficient change management because you can see things clearly and do your impact analysis and conflict resolution early on in the system, which then allows things to tail off to become more smooth in your later phases of your engineering. There was a huge removal of translation errors because we started to move closer towards using a common set of notations and terminology. We were able to define things using a common data language dictionary in a multidisciplinary environment. And this was directly seen when we were doing system specification. We were able to write requirements that satisfied things across different specialisms. So essentially requirements that would satisfy a safety need and will also be able to satisfy to an extent a security need. So there's no need to duplicate requirements and end up with hundreds more requirements when you can have things specified more efficiently. There's also the efficient use of scarce specialist resources and stakeholder resources. When we're doubling and tripling up some of the sessions that we're running or some of the information that we're producing, we are using a lot of resource which can be better, sort of more efficiently used. I think we all know that human factors and I think security and safety and engineers are resources which pretty much every organization I've ever met are always needing more supply of. And we're also able to perform a thorough impact analysis, again, because things are very clearly linked together and traceability is very clear. So those were some of the things that we observed when we applied on a couple of projects that I worked on at the concept level and requirement specification level as well. So I know that was a quick breeze through a number of slides. If there's anything you'd like me to go back to, I'd be more than happy to go back there, and I'll be happy to take questions as well and yeah, have a bit of discussions and know your views on everything I've just talked about.
Okay, thank you, Yewande. Let's see, let's give her a little bit of applause there. Thank you very much. Are there questions? See what questions we have. We have plenty of time for questions. I'm sure there's many out there. Who would like to begin?
Hey, Mike, looks like Sanjeev has a few thoughts that he wants to share. Just been kind of scanning through the chat. So if you wanted to kick us off, Sanjeev, go ahead.
Yeah, this is with regard to which projects you have applied this method. I just wanted to know to begin with. Is it possible to name the projects in which you have applied the reveal process?
So there were early life cycle concept development projects for some ETCS related work. So it's not. It was the specification essentially of ETCS related work. I think that's probably as much as unfortunately I can share. Yeah.
Okay. Now why I say because reveal is a process which has been rejected by the GB Railways because at West Coast route modernization, we have actually used it and found it not fit for purpose. Our project got cancelled after 5 years. The main problem with reveal process is it does not include organizing factors. It does not include interactions between the duty holders, which is required for the common safety method. And if we do not take the requirements of common safety method into account, then down the line, we will have problems.
So I'm not sure what specific experience of reveal you refer to, but the main reference to reveal in this particular presentation is the fact that they've defined the extended context diagram, which I found to be very powerful. So unfortunately, this isn't a reveal sales pitch, and I take that you have the experiences that you have. But I think if I may just skip back to that slide, actually, if it would let me. The main thing that I think needed to be pointed out from reveal was the extended context diagram that allowed us to think about the interactions across the disciplines as opposed to just the interaction between the machine and the system and the operator. Being able to kind of just zoom in a little bit into that is the reference to reveal.
Yeah, you have to take into account when you're applying reveal, you have to take into account the latent failure conditions as a part of human error. If you do not take into account the latent failure conditions which originate from the regulator level and even the DFT, the Cambrian ETCS project had a latent failure conditions which contributed from the UK Department of Transport's mistake. and the ORR's mistake. So this extended diagram as a chain of event model, it looks very good, but unless we take a socio-technical model, we are not addressing anything. You know, we are spending money like we spent on the Crossrail, we spent on the HS2, but we are not able to address the main problem is what is the actual requirement and what are the attributes we desire of that system. You know, otherwise we will have cost overruns, we will have project cancellations, and the billions of pounds have been wasted in the UK over railway projects, and accidents keep occurring.
I definitely take your take your views, and I appreciate your experiences, and I don't disagree with you that we must keep evolving and keep improving things. So thanks for that.
I have my hand up. I don't know if you're looking, if that's...
Yeah, go ahead, Bruce.
So, I mean, just by the way, as someone who no longer has any commercial interest whatsoever in Reveal, work for a university, I did use it once and I found it had some useful things, but that wasn't really the point I was going to make, or the question, I guess. This problem of getting silos to work efficiently together is a very old problem, and clearly one that we have not completely solved. And this is, I appreciate this as a useful, a valuable contribution to tackling it. I would suggest it's one of two parallel methods, in that you're, and I don't think one has to choose between them. Your method is very much about integrating data and process and so on. But the other sort of project manager's method is, well, in extreme, it's an integrated project team when you can afford to have full-time specialist engineers to make them move their desks into a different building and all go to the same bar for margaritas on Fridays. And that was not entirely a joke. So get the people to work, and in slightly less radical ways of working. I went to the facility of your current employer, Siemens, in Braunschweig, a quarter of a century ago. I'm sure things have changed, but at that time the engineering facility had coffee breaks in a coffee room at a particular time, and in the coffee room they laid out drawing tables, and everyone went to their coffee with a rolled up drawing under their arm. And interchanges happened in the coffee room. I guess it's not really a question, although I appreciate your answer. I think we should do both. I think we should integrate the processes and data, and I also think we should build teams by integrating the people. But I'm interested.
I don't disagree with you at all. And in fact, I think you're emphasizing there on engaging the right people. So aside from the processes which we've spoken about, it's also engaging the right people consistently throughout. And you've made a point there about sort of just having that physical space together. Unfortunately, where we are now, especially with COVID, you don't get you don't tend to get everyone sitting in the same room for very often anymore. But what can we do to mitigate that problem? But I completely agree with you. We need to engage the right people consistently. It might be expensive upfront, but I think it makes us future-proof in that we're not trying to fix problems later, and we're not trying to, because I think when I started working on this, one of the first things that I thought about was a lot of our standards, especially sort of safety RAM standards, are driving us in a direction where people are going to go, what's the point of doing all of this? And they're going to find really quick ways of doing it. And it's going to start to make some of our current resources a little bit redundant. So it's what can we do to remain in this space and evolve with the systems that are evolving? Yeah.
Thank you.
Andy, I think you had.
Jenkins.
Yeah.
I have, yeah. So excellent presentation. Thank you very much. It's something that I spotted when I went to the INCOSE workshops over in Europe I think it was in Berlin in 2018, where two guys from different disciplines from Siemens stood up and talked about the RAM engineer and the security engineer and the HF engineer working together in an integrated project team. And there's a big gasp in the audience of what? But I guess it goes back to East London Lion with Alan. Alan he's not with us anymore, but when we were trying to get all the teams working together, it's always a big problem. On our last project, working on an ETCS, I was a SEM, system engineering or solution engineering manager. But it was interesting to me, you mentioned doors, but I kind of mandated that each of the teams would go and do their analysis and so on, and have the hazard IDs and so on and so forth for all the specialities. But the mandated, but they can put it in a spreadsheet, but it must come back into my doors system. Obviously, we had all the requirements there, the client requirements, the standards were in there, but everything then got a doors ID, and we could then interlink those. And what we ended up doing was putting together like an N-squared table where each of those touch points would touch, and then we'd say, okay, security, you can lead on this, but the hazard person or the RAM person or whoever would then come in and answer that analysis. But the key thing, as Bruce mentioned, then it's that integrated project team, and it can work, but you do have to kind of be I don't know what the right word is here, but kind of mandate it as a SEM or as a project manager, whoever's leading that and gluing the team together, which inevitably is a system engineering manager and as a system engineer, it's about gluing all those together. And as you mentioned earlier, with the systems at the moment and the capabilities of the systems and the technology, you have to have that approach, because you'll get the Swiss cheese model and you'll find it going through the whole.
Yeah.
And if you don't do that, But excellent presentation.
Thank you. Thanks for your contribution as well. Yeah.
Yeah, just gonna throw my thought into this. I echo everybody's comments. Very well done, Yewande, and really appreciate you taking the time to share this with us all. One thing that I've noticed, and it's a bit more of a general trend, but I think as humans, we, maybe since COVID or perhaps it just amplified it, we're starting to get somewhat binary in the way we interact. And, we tend to have these yes, no, on, off conversations or discussions through social media. I try not to touch it, but I see it happening around me. And so one way we're trying to combat that is to, and this is kind of segueing off what Bruce had mentioned earlier, where you physically, try to get the teams together to socialize. If you can't physically do it, you can figuratively do it. And, through brown bag, lunch and learns, or whatever you want to call it. And, let's take a look at the, on these large projects, there's many silos. So let's break down the silos by having each, silo present to the other silos and say, hi, this is us. This is what we do. This is where we need your help. How can we help you? Kind of a conversation because I think we have to relearn how to socialize. I hate to say that, but that's something that I'm seeing. And, not, present company accepted on this call. A lot of engineers aren't great at socializing anyway. It's like going to a high school dance and they're all, the ones leaning against the wall, too shy to move forward, kind of thing. So that's just my thought, and really, really appreciate you bringing this conversation point up. So thank you.
Thank you. I think Wendy's hand is up.
Yeah. Wendy?
Yeah, just a few thoughts going around my head. One is following Andy's comments, as similarly the better rail. I work cross sector, and I've spent quite a good portion of time in the rail sector, and the better projects that I've worked on have utilised doors. They're ones who have utilised doors to its best effect. So, the requirements, the hazard records, etc. Neatly tagged, in the security assessments, etc. So that you could easily cross-reference, and such that the data that was being captured was easily auditable and traceable, which is really important for V&V. obviously, and yeah, third-party assessors. So that was one of the first thoughts. The other, which a few other people have touched on, is integrated teams. I am a great fan of integrated teams. I much prefer not being put in a silo when other people being doing silos. And I do honestly believe that the better integrated teams are, the better the results, and the quicker, also the quicker the jobs as well. Because yeah, siloing the HF and safety, systems engineer, etc. You then got to deal with the interfaces, whereas if you've got a more integrated team, the interfaces can almost crumble away. Melt, and project managers love that. So if you say, if you can say to them, well, if we are all sat in a room together, whether it's virtually or in person, and we can get the job done 3 times as quick, they're usually quite happy about that. So yeah, so that was my observations. But yes, interesting presentation. It's, as Bruce said, it's the topics covered here span back many years, but these days we've got you should have the technology to move forward and get over some of the problems we've had in the past about this integrated assurance is yeah, a good thing to aim for. Yeah,
and I completely take what you said, and this is one of the reasons why this particular brown circle here was quite an interesting discovery for me, because like you said, we have the technology, we have the tools, we have the knowledge to know what we should do now, but because people are so comfortable in this sort of historical processes, and they've been doing things the way we were doing it, one of the things that I didn't write this down, but in my experience, is that people can very easily default to the way they do things when it gets a bit difficult, or when it gets a bit expensive. It's easy to go back to we're used to doing this in the way we're doing this, but we're not going to survive if we keep going back to that because we're used to it. Yeah.
Very good. Try and lower my hand. Right.
And for what it's worth, which is not very much, so pardon some ramblings, I have this picture in my mind for split site projects where people are generally in 2 places, that you could have the coffee room in each of the sites have a full-sized screen with a view of whoever's in the coffee room in the other site. So you could bump into them virtually, even if you were thousands of kilometers away, and just chat. But there is some value in that just chatting. It spots things that structured communication doesn't always spot, in my experience.
I really agree with you, Bruce. I worked on a project back in 2007, and it's the feed into East London line. We had a team in Manchester, London, Paris, and Bilbao. But our project manager mandated that every month we would go to one of those sites, and we'd have the technical meeting, but the value meeting was having a coffee and going for a beer or some food after. And the amount that was learned during that time, then it was the people it wasn't a technical integration, it was the people integrating. We just got to know each other. And when the proverbial hit the fan on his London line, I remember when everybody had to be on site, and it was a crazy Christmas in 2009, I think it was. But the team flew in from Bilbao when we needed them, and they were there. And they came with their technical skills, but it was that people and how the people integrated. And it's those soft skills are so important to allow everything else to work together.
And I wouldn't like you to think, Yewande, that I was any of this was at all critical of what you're suggesting. I'm thinking I'm thinking this is such a big problem. It needs a pincer approach with more than one line of attack.
Absolutely.
And thank you for the presentation.
Thank you. Back to you, Dale, I think.
Yeah, sure. No, just to kind of tag on to what was just said about the people part of it. One of the things when we do exit debriefings or exit interviews and folks coming on and off projects, one of the things that always comes up is, the technology actually isn't that hard. We've solved some of this stuff 10, 20 years ago. It's always the people. So that's the comment that just always keeps coming, and that's kind of where I was getting at too, with just the socialization and the importance of creating an integrated team, sort of not just saying it, using corporate speak, but actually doing it so people really feel bonded. They've been in the trenches with each other and they want to try to support each other, and that's broken on a lot of the projects I've been on recently, to the point where it's actually a reason that people leave, as opposed to, and yet maybe Doors was set up well with good links, as somebody else had mentioned. I think Wendy had mentioned earlier, where we have the capability to use these sophisticated tools, and we've got wonderful digital engineering, information exchange discussions going on between the tool suppliers, which will hopefully result in making it even easier. I doubt it, but we'll see. One lives in hope. But yeah, I just wanted to re-emphasize that I think it's the social aspects. In fact, it's one of the reasons I used to be the membership director of INCOSE Chicagoland, and I'm heading to a meeting there in about half an hour. And one of the main reasons people said they joined and they spent the $150 whatever it is for INCOSE each year was for that social interaction between like-minded individuals. So that always left an impression on me, that's really why people are here, is obviously to gain knowledge, but at the top of the list it was kind of a little bit of commiserating and bonding in the trenches. So anyway, I'll stop on that note. Any other questions or thoughts? Mike, did you have any?
Yeah,
no, I think you covered quite a bit. I think that
one
it's
thing
good
she
for.
wanted to know.
Oh, Sanjeev.
Go ahead, Sanjeev.
Yeah, sorry. She wanted to know where the reveal process was applied before. It's actually 20 years ago. It was applied on the ETCS ERTMS project as a joint venture between Alstom and Network Aware. And this was and we had used also the integrated project team. We were all co-located, and we spent about 600 million pounds in total, but we couldn't get the system specification for ETCS ERTMS. And that's been the problem, I think, even till today. HS2 did not have or has not written a system specification yet, or if they've written, it's got a problem with it. And the Cambrian ERTMS also, they had a IPT, and then they had the single point citing of all system engineers. But when the RIB investigated, they found that the processes did not help much to identify the single point failure of the radio block center. One sore point still remains is, how do we incorporate the lessons which we have learned from past failures and incorporate them at the concept level so that we don't repeat them? Getting the tools and getting the, reveal has been there for almost, if I can remember, in 1992 it was started. I forget the name of the company that started it. I think Capgemini took over that company. And I met, in fact, I worked with many of the people who actually developed the reveal process. This was in from 2001 to 2003. And what we found is, it's we do not have yet the notations which can facilitate common definitions For example, people tend to use UML, SysML, and the use cases and the functionality related to use cases. But the human factor engineers and the system safety engineers, they have to go at a higher level and look at the system that can actually generate the potential hazards, so that the actual safety requirements can be taken out, rather than the hazards which are actually put by safety engineers into the hazard records, stating that these are the hazards which we faced last time, but they actually do not appear in the new technology. Now, these are the just few thoughts which came to my mind, because with each different technology, say for example, level 3 ERTMS has got a different list of hazards attached to it rather than level 2 ETCS. And then ETCS level 1 will have a different set of hazards attached to it, because the system definitions are different from one level to another. I don't know whether you face this problem during your concept projects or not.
I mean, well, certainly, I take the main points you've made, and there is always a place for continuously improving. I mean, I know you've mentioned a reference project from 20 years ago, perhaps, and I also know that the reveal process has gone under a few iterations, but this wasn't trying to be a reveal sales pitch. It was more of just taking sort of notes from what has been used before. But when you mentioned specifically, for example, about hazards management and how it's done, my understanding is that there is a level of hazards at different sort of levels of abstraction of the system, so that there's hazard management at different levels. So whether you're talking about the operational level, or you're talking about the system level or subsystem level, however you kind of split your system. But it's quite a complex question, so I don't know if I've answered all of it. But I suppose my summary to respond to you is, we are always learning. I've taken some ingredients that I think can work from a number of experiences that I've had and research that I've done. And I think that with respect to things like hazard management, it's done at different layers, and all of those layers interact. And it's about ensuring that we can close the gaps as we're doing the engineering, and we're continuously improving and evolving the way we do things to make it better.
If I can add something on that one. Go on ahead, Sanjay.
Why I am raising those two? Yeah, sorry. And now why I'm raising this point is because if you look at the Boeing 737 MAX 8, and if you look at the cross-rail integration of 3 signaling systems, you know, at the highest level of abstraction, system engineers do not get access to, because somebody else has made the design, implementing that design decision, you know. I don't know whether my point of view has come across clearly.
Sorry, I wasn't sure if that was for me to respond.
Hey, Bruce, did you want to jump in?
Yes, well, in so much. One of the quotations that I love is from the American statistician George Box, who wrote, "All models are wrong, some models are useful." I used to know and respect a great deal Dr. Anthony Hall, who was one of the architects of Reveal. I don't think he'd ever have claimed that it was a panacea for all things. His view certainly was, I guess, he didn't say this, all processes are wrong, some processes are useful. And he certainly advocated a mixture of processes integrated together for designing systems. And while we're waiting for the perfect process that integrates all of these, I'm reasonably content to mix and match and take the strengths of various things and try and get the data integrated, just as Yewande says. Again, just my view.
Thanks, Bruce. And I don't know if Bruce, if you or Mike want to we got a minute. Just mention the November webinar coming up.
Oh, yes.
Oh, right.
Want to do that,
Bruce.
Mike?
I think you should. I mean,
Okay.
you know the
Yeah,
details.
I've got a real personal interest in this because the November one, 3 of my students presenting their research projects, all of which in very approximate terms are looking at the soft aspects of engineering, but trying to apply some rigorous systems thinking to it. And it's going to be a little bit early, I'm afraid, for those on the West Coast, because we're doing it in London, and people in London go to events before they go home. So 5:30 UK time, still perfectly doable, I think, if you're on the West Coast. It's going to be great. Please come.
It'll be at the same location as the TFL, like we did in September. We had a hybrid event. So 7:30, I think, show time. It goes for an hour at 17:45, ends at 16:45. We're getting the flyer together, but it'll be that kind of event. And for those who are in London, well, this is a great time. Yewande, you may want to attend if you're in London. We've just started this. This is the post-COVID era now, so we're trying to do this in a very rational way, but at least allow the kind of gathering and socialization that we had before. Bruce, did they actually go to a pub last time? No, he's not there.
No, I am here. Just muted. Yes, we did. The Goose in Selly Oak. And very noisy it was indeed. So this time, well, I don't know, haven't decided. But if you want to come for a drink with us, you'll have to come to Southwark.
I wish I could. Well, thanks guys. And then we've got one coming up in a different, it's not the third Thursday in December, and we'll get that flyer out as soon as we can, since it's a different time. The 21st was too close to to Christmas to try that one. So we have 2 more webinars coming up. I'm really excited about the one that Bruce is organizing for next month. So that stay tuned for the flyer on that. Mike, you and I'll have to coordinate because the time's changed, and I'll have to try to get into the Zoom account. And
okay,
it might end up being a different link. I hope not, but we'll figure it out.
Okay. And the one you're doing in December, is it New York City Transit?
Yeah, that's myself, New York City Transit, and TransLink, William Huey in British Columbia, TransLink.
Oh, wow. Okay.
And,
very good.
It's so Bill Gleckler at New York City Transit. So excuse me. So just looking forward to that too. And also I was going to briefly mention, I guess folks know that IW is coming up. It's in its typical spot, although I did hear rumors that they were going to make IW go international, like off the US the following year. I don't know if that's true or not, but for this coming year, 2024, it is back in basically LA. It's in California, Torrance, California. So thanks everybody. I really appreciate everybody's attending this, and Yewande, thank you very much once again from all of us. I got my mic on, so I'm clapping. Hear it or not, but really appreciate it, and it really got people thinking, I think. So well done.
Thank you very much.
Right.
Thanks for having me.
Thank you. Yes, anytime, Yewande. Take care, everybody, and have a good evening here in the UK and a good afternoon there in the US.
Thanks.
Bye now.
Thank you. Bye.
Bye all.
Thank you. Ciao.